Let's understand call stacks. Let's say we have a program where we have the main class and a class named playing_die. In the playing_die class, let's say we have an attribute named current_value and a method named roll. What this method does is very simple. It selects randomly an integer from 1 to 6 and then stores that in this.current_value, which is the attribute here. It then returns whatever is stored in current_value. In the main class, we have the main method as well as a custom method named roll twice and add. What that does is it creates a playing_die object and then rolls it twice, sums it up, and returns that sum. That's all it does. So basically what's happening is that we're simulating rolling a die twice, adding it up, and then printing it in our main method. Let's see what happens if we run this program. Our program gives us an output of 6. So what has happened in our program? At first, we want to print something out in our main method, and that is our very first statement. We call the roll twice and add method. The program comes here. It creates a playing_die object, d. It creates an integer named sum. It then calls the roll method of the object d. Whatever result comes from this method will be stored in sum. So what's happening in the roll method? Let's go to the playing_die class. In the roll method, we are calling math.random method. And by doing some mathematical operations, what we do is we get a number from 1 to 6 randomly. The main thing to focus on here is the usage of math.random method. Great, so math.random method is called, we get the value, we store it in current_value, and then we return that value back to where the method roll was called. We store that value in sum, we then call roll again, and the same process happens again. It goes to the playing_die class, calls the math.random method, returns a value, comes back here, and then adds that value to the already existing value of sum. Once we have the value of sum, we return it, and the program comes back here. Now roll twice and add method has its result, which is ultimately printed in our console. What's happening internally in Java is that a call stack is being created, starting from the very beginning. So let's say we just started our program and our call stack is basically empty. The call stack is what a program uses to keep track of the method calls. The call stack is made up of stack frames. Each stack frame corresponds to one method call. So let's see what's happening in our program here. At first, we call the roll twice and add method. A stack frame is pushed in our call stack. That stack frame belongs to roll twice and add method. So this stack frame is the first element of our call stack. So our program calls roll twice and add and comes here. Here it creates a playing_die object, it creates the integer sum, and then it calls the roll method. Since now a second method has been called and roll twice and add is still waiting for a result, this second method is now added to our call stack. So now we have a second stack frame which is pushed on top of our roll twice and add stack frame. So this is how our call stack looks right now. Now the program is still here. It did not go here to this next statement yet because the roll method has been called. So it now goes to where the roll method has been defined. It goes to the playing_die class and comes here. Here, some value is being assigned to the attribute current_value, but here a third method has been called, which is math.random. So roll is still waiting for a result, and math.random has been called, which means that this now goes on top of our call stack. So now a new stack frame for math.random is pushed on top of our call stack. Math.random does its thing. Whatever it needs to return, it returns. And ultimately, we have an integer randomly chosen from 1 to 6. So math.random at that point has completed its task. Whatever value we get, it is then stored in current_value. At that point, math.random stack frame is popped from our call stack because it has completed executing. So now math.random stack frame is not there anymore in our call stack. This returns a value where roll was called, and that result is now stored in sum. At this point, the roll method has also finished executing. So the roll stack frame is popped from our call stack. Now the program goes to the next statement. Here, the roll method is called again, and so a new stack frame for the roll method is added to our call stack. It now goes back to the playingDie class, where it finds the roll method and starts executing whatever we have in the roll method. The math.random method is called again, and so the math.random method now goes on top of our call stack. Once the math.random method finishes execution, it returns whatever it needs to return, and we have a result for this statement, which is stored in current value. Because math.random has finished execution, the stack frame for math.random is popped from our call stack. The roll method returns a value. The result is added to the integer sum. At that point, the roll method has finished execution as well. So now this stack frame for roll method is popped from our call stack. The roll twice and add method returns the sum back to where it was called from. And so now we have a result here, which means that the roll twice and add method has also finished execution. Since it has finished execution, the stack frame for roll twice and add method is also popped from our call stack. Our call stack is now empty, everything has finished execution, and our program now outputs the result in our output console. So this was a brief overview of what call stack is and what it looks like when we run a program that is calling a lot of different methods during its execution. Remember that when we are not creating threads, we only have one thread, which is the main thread. And if we only have one thread, everything happens in the same call stack. We have only one call stack, and stack frames for different methods are pushed or popped from that single call stack. Please keep in mind that system.out.println is a method in itself. So the very first stack frame to go into the call stack would have been system.out.println method. But for simplicity, we started with roll twice and add. If we look at the program that we wrote in the last video, where we had multiple threads, what would the call stacks look like? At the beginning of our program in the main method, there is a call to download extends threads constructor method. In the call stack of our main thread, the very first stack frame is therefore the download extends thread constructor. Right after this statement, the constructor finishes execution and the program moves to the next statement, which means that this stack frame will now be popped from our call stack of the main thread. Since the program is now calling the system.out.println method, that method now goes into our call stack for the main thread. At the end of this statement, the system.out.println method has finished execution, so it is popped from our main thread's call stack as the program moves to the next statement. The next statement calls the start method for thread T1. So now we have this method in our call stack. And this is where something interesting happens. Because we are calling the start method to start a new thread, this new thread starts with its own call stack. So now thread T1 has its own call stack. And when we call the start method for T1, since T1 is an instance of download extends thread, the run method of the download extends thread class is called. And now this run method now goes into the call stack of thread T1, at which point the start method for T1 has finished execution. So it is popped from the call stack of the main thread. The program now comes here, and the system.out.println method is called from the main thread. So that method now goes into the call stack for the main thread. Keep in mind that when all of this is happening in the main thread, thread T1 is running simultaneously. The thread scheduler assigns a little bit of time to the main thread and also a little bit of time to thread T1 so that both of them can run simultaneously. Once system.out.println has finished execution, it is popped from the call stack of the main thread, and then the program comes here. Here, it's calling the constructor method of download implements runnable class. So now this method goes into the main thread's call stack. Once our dir object has been created, this method is popped from the main method's call stack. The program then comes here, and we're calling the constructor method for thread class. So that now goes into the main thread's call stack. Once the thread object T2 has been created, the thread's constructor method is popped from the call stack. The program then comes here, and then system.out.println is the next method to go into the main thread's call stack. Once that has finished execution, the program comes here, and the system.out.println method is popped from the main thread's call stack. And the start method for T2 is now pushed into the call stack for the main thread. At this point, a new call stack is created for thread T2. And the run method from download implements runnable goes into the call stack of thread T2. In the main method, this has finished execution, and the stack frame for this method is popped from the main thread's call stack. The program then comes here. The print line method goes into the main thread's call stack. Once it finishes, it's popped from the call stack. Now, while all of this is happening in the main thread T1 and T2 are running simultaneously. Let's look at what happens in T1 while the main thread and T2 are also simultaneously running. There is nothing more coming into the main thread's call stack because everything in the main thread has been executed by now. The first method that's called in the run method is the system.out.println method. So that goes into the call stack for T1. Once this method has finished execution, it's popped from the call stack for T1. After that, the sleep method is called. So that now goes into the call stack for T1. After that, the sleep method waits for 1.5 seconds, at which point it finishes execution and is popped from the call stack for T1. We then call the download method. So the download method now goes into the call stack for T1. From here, the program directly goes into the download method's definition, where at first the system.out.println method is called. So that goes on top of the call stack for T1. Once it has finished execution, it's popped from the call stack, and then the sleep method is called, which now goes on top of the call stack. The sleep method waits for 6 seconds before it finishes execution. After it finishes execution, it is popped from the call stack for T1. Since we do not have anything returning from the download method, the program goes back here and the download method at this point has finished execution. So it is popped from the call stack for T1. No exceptions have been caught, so the program does not get in here. It comes directly here. The system.out.println method is called, which now goes into the call stack. Once this has finished execution, the method is popped from the call stack. At this point, the run method has also finished execution. So it is popped from the call stack for T1. Now, everything that this thread needs to do has been completed. So the thread is terminated, and so it does not need a call stack anymore. As all of this was happening, thread T2 was also running simultaneously. And since we have the same code for thread T2 that we had for thread T1, the same thing happens in thread T2 as well. And once it terminates, its call stack goes away as well. So our program has finished execution at this point. The goal of this video was to convey the fact that whenever a thread is started, a new call stack is created, and everything related to that thread happens using the call stack for that thread. That is how Java works on different threads at the same time. A further thing to note here is that T1 is an instance of download extends thread. Download extends thread has a run method. So if we create a download extends thread object, which is T1, we can call the run method directly instead of calling the start method. And if we run the program now, we'll see that things are happening in a different order. At first, T1 finishes downloading, and then T2 starts downloading. 6 seconds after that, the program finishes execution, and we're done. Why did this happen? This is because when we call the run method instead of the start method, the run method goes into the call stack of the main thread. A new call stack is not created if we do not call the start method. So if we are to run anything using a thread, we should always call the start method for that thread and not the run method, because the run method does not create a new call stack for the thread. And if a new call stack is not created, then the thread does not execute simultaneously with other threads. The execution at that point is sequential. So we should always call start method when trying to carry out a task using a thread object. So in this video, we looked at call stacks, and we looked at how using the start method creates different call stacks for different threads. We have also understood the difference between calling the start method and the run method.